Alayon, and we are to be discussing a concept of mathematics that we probably encountered way back, and that is what we call antidifferentiation of transcendental functions. So I'm going to give you a short intro about my topic by a word-to-word discussion, which is antidifferentiation and transcendental function. So first, antidifferentiation. It is the opposite of derivatives. So we can also call it as antiderivative. So an antiderivative is a function that reverses the derivative does. One function has many antiderivative, but they all take the form of function plus an arbitrary constant. That's why we are putting plus c in our answer. You can also watch the video of my groupmate, Mr. Lamarosa, for further discussion. So as we all know, there are a lot of types of functions. There is linear function, rational function, radical function, and even quadratic function. And this type of function is what we can only encounter in calculus. So in mathematics, transcendental functions are functions with a not expressible in final combination of certain algebraic expression such as addition, subtraction, multiplication, division, raising power then exponent, and extracting of square root. So examples include logarithm, exponential function, and certain quadratic function, and trigonometric identities such as sine, cosine, and tangent. So this expression can only be expressed as infinite series of functions. So why transcendental functions? Because this is more technical and scientific application of the functions I mentioned before, which is the logarithm functions, exponential functions, and trigonometric functions. So in general, transcendental functions means not algebraic. And thus, we all need to know about antidifferentiation of transcendental functions. Some of the rules of the antiderivatives. So some of the rules that we will apply is antiderivative of a constant, which is c of x is equals to the antiderivative of this is c of x plus c. You can watch the video of Mr. Lamarosa for further discussion about this topic. And here the derivative of 1 over x also equals to x negative raised to the negative 1 is equals to ln of absolute value x plus exponential function e to the x is equals to e to the x plus c. And by this formula, we will be able to identify the given functions. So we will also introduce the antiderivative of trigonometric functions. So here is the derivatives and the antiderivatives. So the derivative of the derivative cos x, the antiderivative of this is equals to sin x plus c. Sin x is equals to negative cosine x plus c. 6 squared x is equals to tan x plus c. Cosecant squared x is equals to negative cotangent x plus c. Sec x plus tan x is equals to sec x plus c. Cosecant x cot x is equals to negative cosecant x plus c. So here we have additional trigonometric antiderivatives of tan x, which is equivalent to the antiderivative of ln absolute value sec x plus c. Cot x ln absolute values sin x plus c. Sec x or secant x is equals to ln absolute value of secant x plus tan x plus c. Cosecant x is equals to ln absolute value of cosecant x minus cotangent x plus c. So under the trigonometric identities or trigonometric function, there is hyperbolic functions. So here we have the integration of hyperbolic functions, which is the antiderivative of hyperbolic sin x dx is equals to cos hyperbolic cos x plus c, and antiderivative of cos x dx is equals to hyperbolic similar to the antiderivative of this, but you can see that there is a hyperbolic sign, which is the symbol H at the end of our trigonometric identities. So here we have also the common hyperbolic identities, and as you know, there is also identities for trigonometric. So here I have the hyperbolic identities, or hyperbolic of sine x is equals to ex minus e to the negative x over 2. Hyperbolic of cos x is equals to ex plus e to the power of negative x over 2. Tangent hyperbolic tangent x is equals to hyperbolic sin x over hyperbolic cosine of x, and so on and so forth. So as we answer our discussion later or exercises, try to familiarize all of this so that we can be able to answer our topic or exercise later. So here I prepared some of exercises or problems, and this is the formulas for some of the problems that I will present today. So first problem here is, so here as you can see there is a symbol like F, and we can call it as a symbol of antiderivative. So here antiderivative of 3e to the power of x plus 7 sec squared x dx is equals to 3ex plus 7. The antiderivative of sec squared 6 squared x is equals to tan x. Tan x. And don't forget to put plus c. So this is the answer for this problem. So our second problem is antiderivative of sec x dx over square root of 4. It's also equals to 1 square root of 4 antiderivative of sec x second x equals to the square root of 4 is 2, so 1/2. Then antiderivative of second x is equals to ln sec x plus tan x, and don't forget to put plus c. So the answer of this is 1/2 ln absolute value of second x plus tangent x plus c. So the sample problem number 3, antiderivative of a to the power of 2x times a to the power of negative x dx. So it is equals to antiderivative of e equals to x minus x dx. So we can solve this for subtraction. So antiderivative of e to the power of x dx, and the antiderivative of e to the x is equals to ex plus c. So for our number 4 problem, antiderivative of e to the x over 4 plus e to the negative x over 4x. So it is equals to antiderivative of e to the x plus e to the negative x over 4 dx. So this is also equivalent to 5. And the derivative of quantity of hyperbolic cos x minus hyperbolic of sin x dx is equals to hyperbolic of cos x is equals to hyperbolic sin x minus the hyperbolics, and the derivative of sin is equals to hyperbolic cos x plus c. The sign here or sin here is negative. So equals to negatives, hyperbolic negative of sin x minus hyperbolic cos x plus c. So the problem for number 6 is antiderivative of 3 over negative x dx is also equals to the derivative of negative x dx. So this problem is negative 3 ln absolute value of x plus c. So this is the answer.
천진 나만 청순 가련 새침한 척 이젠 지쳤나 귀찮아 매일 뭐해 어디야 밥은 잘자 baby 자기 여보 보고 싶어 다 부질없어